Hey guys, today we're doing Chapter 3, Section 7, which is on composition of functions. So suppose f and g are functions. The composite of g with f, written g with f, is the function defined by g with f of x, which is also the same thing as saying g of f of x. This right here, g of f of x, is the way that I prefer to write it, and that's the way that I'm going to write it on all your tests and things like that. So just make sure that you understand that one. Basically, the reason I like it this way is because when we're doing order of operations, remember that we always do our innermost set of parentheses first? Well, that's the way the composition of functions works. Here, looking at this, I start with my innermost parenthesis, which is x, and then I work my way out, so I do x, and then I do f of x, and then I do g of f of x. So let's say that f of x is x squared plus x, and g of x is x minus 5. And I want to find the following, f of g of 7. Well, I'm going to start with my innermost set of parentheses here, which is 7. Okay? And if there was anything in here, any sort of operation that I had to do, I'd do that first. Then I'm going to do g of 7. So basically what I'm doing is I'm plugging 7 into my g. Okay? So after I plug 7 into my g, that gives me 2. Okay, so now what I'm going to do is I'm going to plug 2 into f. So once I do that, I have 4 plus 2, which is 6. So f of g of 7 is equal to 6. Now I'm going to do the same thing for g of f of 7. So again, I start with my innermost set of parentheses with 7. And then I take 7 and I plug it into f. Okay, 7 squared plus 7. That's 49 plus 7, which is 56. So now I can plug 56 into g. And that gives me 51. So g of f of 7 is 51. Okay, it starts getting a little bit more complicated once I have x. So once I start using variables instead of numbers. Because with numbers, it's pretty easy to just get to this step, and then you've just got an easy problem to plug back in. But with variables, you have to kind of simplify and make sure that you're doing all your order of operations properly. So f of g of x, I'm going to start with x. And basically, I'm just going to replace this g of x here with my actual function g of x. So I have f of x minus 5. So now what I'm going to do is I'm going to plug x minus 5 into f. So I have x minus 5 squared plus x minus 5. It's really important to remember that when you're plugging these in, you have to put everything in parentheses. Because, for example, if I forgot the parentheses here, I just have x minus 5 squared, which isn't the same thing as the quantity x minus 5 squared. Okay? So now that I've got that, I'm going to go ahead and simplify this now. So x minus 5 squared, that's just going to be x squared minus 10x plus 25 plus x minus 5. So when I combine my like terms, I get x squared minus 9x plus 20. So f of g of x is x squared minus 9x plus 20. Now I'm going to do the same thing with g of f of x. So I'm going to start by replacing f of x with my function for f of x. So I have g of x squared plus x. Now I can plug x squared plus x into my function g. So I have x squared plus x minus 5. Now I go through and I do any simplification. I notice there's really not anything I have to do except for get rid of those parentheses, so I just have x squared plus x minus 5. Okay, and that's going to be my g of f of x. So that's essentially the gist of composite functions. There are some properties of composite functions that we want to think about, for example, domain and range. So if you want to find the domain of a composite function, the domain is basically the set of values of x in the domain of f, for which f of x is in the domain of g. And that sounds kind of confusing, but it's actually not that bad. Essentially what you're talking about is if you just find the composite function before you actually simplify everything, that is how you can find the domain. So if I look back at my f of g of x, okay, this step right here, this quantity x minus 5 squared plus x minus 5, that is before I did any simplification. So that is the part of the problem that I would look at in order to find the domain. If you go through after you simplify, you could get rid of some important information in finding that domain. So it's really important that you don't want to look at the end result when you're looking for domain. You want to look at the unsimplified version. So consider the example, f of x equals the square root of x. What is the domain? So what would the domain of this function be? Well, I know that underneath the square root, I can't have negative numbers. I can have 0. So I'll say that the domain is going to be all real numbers greater than or equal to 0. Okay, let g of x be x to the 4th. Okay, and the domain of this, of course, would be all real numbers because you could plug anything into that and you could get something out. We want to find g of f of x and its domain, and then we want to sketch the graph. So if I want to find g of f of x, I'm going to start by replacing f of x with the actual function for f of x. So this is going to be g of the square root of x. So now what I'm going to do is I'm going to plug the square root of x into my function g. So then I have the square root of x to the 4th. Okay? So now I can go through and simplify. Well, the square root of x, that's just x to the 1/2. So this is x to the 1/2 to the 4th. Using my exponent rules, I just multiply those together, and that gives me x to the 4/2, which simplifies to x squared. Well, thinking about this function, x squared, I know that the domain of that is just all real numbers. But remember that when you're looking at composite functions, you always want to look at the unsimplified version to find your domain. So this right here would be my unsimplified version. And looking at that, my domain cannot be all real numbers because I can't plug negative numbers into that. So the domain of this composite function would be all real numbers greater than or equal to 0. Because those are the only types of numbers that I can actually plug in here. Now on your graph, if I want to sketch this on my axes, well again, you want to type in your unsimplified version to your graphing calculator. If I type in x squared, that's just going to give me a parabola. But if I type in the square root of x to the 4th power, now that's only going to give me 1/2 of the parabola. It's going to give me the positive side of the parabola. So on my graph, it's just going to give me this portion of the parabola. Okay, so starting at your 0, 0 and going up, everything else is not actually part of my function, so it would not be part of my graph. Now let's let f of n be 13 minus n. What is the domain of that function? Well, if I think about it, 13 minus n, can I plug anything in for n? The answer is yes, so that's just going to be all real numbers. Let g of n be 2 over n plus 1. Now I want to find g of f of n, and I want to find the domain. So g of f of n, I'm going to start by replacing f of n with the actual function. So this is going to be g of 13 minus n. So now if I plug 13 minus n into my g, I get 2 over 13 minus n plus 1. Okay, now I can go through and I can simplify. So if I think about my denominator here, 13 minus n plus 1, 13 plus 1 is 14, so this is actually just going to be 2 over 14 minus n. Okay? And that's all I can do to simplify, so that's going to be my final answer. Now, it asks me to find the domain. So again, remember that you always want to think about your unsimplified version, which is right here. Now, did I really change anything going from here to here? I didn't. I didn't really change anything. So, thinking about my domain, the domain for these two functions is not actually any different. If I think about the numbers that I can't plug in here, well, the only problem I have is that I can't divide by 0. So anything that would make this bottom portion, or my denominator, 0, would be something that can't be a part of my domain. So I can think about what would make that 0. So this is just 14 minus n equals 0. If I subtract 14, I get negative n equals negative 14. So n equals 14. So basically, the only thing that can't be in my denominator is 14. So my denominator is all real numbers except 14. And notice that you could have gotten that from the simplified version as well. So you really want to pay close attention when you're doing domains of composite functions, because every problem is different. Probably your two biggest things that you need to be worried about when thinking about domain is that you can't divide by 0 and you can't have a negative underneath the radical sign. Besides that, there shouldn't be any big things that inhibit you from having all real numbers in your domain. Alright, that's everything for section 7.